Okay, for those who not signed the attendance, please do so because we will begin our class shortly. Okay, so without further ado, let's begin our class here. Okay, so in the previous class, we already learned about how to do a loops. Okay, you have learned about while loop, for loop, do while loop. Okay, now we are going to see another what we call here another statement. Okay, why which is used for the decision making. All right, so the decision making structure requires that the programmer specifies one or more conditions to be evaluated or tested by the program. Okay, you have a if you have a few conditions, you can use this statement in order to evaluate it or test it. If the condition is met or true, then you will proceed with execute the statements. Okay. So we have a few what we call here decision making here. Okay, by using the if else statement. Okay, you have the if else statement as well as the switch. All right. So this if else statement can be divided into four parts. Okay, which is using a if statement only, and then you have an if else. Okay, for the if statement you see here, you only have one condition, right? So whenever the condition is met or true, then what happens is you do the statement inside here. Okay, for if else statement, you have two what we call here conditions. Okay, but the first condition is okay, you need to see whether it is true or not. If true, you execute this is the statement under here, while if the condition is false, then you need to do this statement here. Okay, then we have a if else if. Okay, if you have more than two or three conditions, you can use this one here, and then we have another if else statement, which is we use a nested if. Okay, later we will see more detail on these if else statements. Okay, and then the other hand, we have the switch. Okay, so this switch here by using a case instruction. All right, so later we will see the details on this switch statement as well. Okay, so this is the basic if statement. Okay, you have the if else, if, and then a nested if statement. Okay, so first we look at the if statement. Okay, an if statement consists of Boolean expression followed by one or more statement. Okay, as you can see, this is the flow chart here. You have one conditions. All right. Okay, please excuse me for 1 minute. I need to take my phone call. Okay, let's continue our class. Right, so this is the flow chart here. Okay, so you have a condition. Okay, if the condition is true, what you're going to do is you need to do your conditional code or your statement here. Okay, you have if the condition is false. Okay, if you can see it, so we exit our if statement. Okay, we do nothing. So this is for the if statements. So let's look at this example. Okay, so in this example here, we are going to check whether the variable a is smaller than 20 or not. Okay, so in this case here, the condition for this statement is we want to see whether we want to check whether the variable a is smaller than 20. If the variable a is smaller than 20, what happens is you need to print out this statement. Okay, if not, then we exit this the if statement and then return what is the value of your a. Okay, so this is for the if statement. And then we want next is a if else statement. Okay, so an if statement can be followed by an optional else statement which execute when the boolean expression is false. Okay, whenever the boolean expression is false, then you if you have another statement to print out whenever the that condition is false, then we can use the if else statement. Okay, so this is the flow chart. Okay, again you have a conditions. Okay, so you need to check whether this condition is true or not. If the condition is true, so you can what we call here, you can execute the if the statement okay, under the condition if true, or else if the condition is false, then you can print out, okay, you can execute the else code here. And then after that, we exit the if else statement. Okay, so in this case here, okay, again, the same, what we call here, the same example as a previous one. All right, so this one we're going to see whether the variable a is smaller than 20 or not. If the a is smaller than 20, then you will execute this statement here, which is a is less than 20. Else, if the a is bigger than 20, what happens is, okay, a is not less than 20. So in this example, if you see here, the variable a is equal to 20. So the statement that will be print out here is the else statement. Okay, so a is not less than 20. Then you give the value of your a. Okay, next we have the if else if statement. Okay, an if statement can be followed by an optional else if else statement, which is very useful to test various conditions using a single if else if statement. Okay, for example, you have various conditions you're going to check. Okay, you want you want to compare various conditions. So you can use the if else if statement. Okay. So in this case, okay, in this example here, okay, as we can see, we're going to check whether our variable a is equal to 10, or is it equal to 20, or is it equal to 30, or the variable a has different numbers. Okay, so you have four conditions here. Okay, the first one here, is it equal to 10, or is it equal to 20, or is it equal to 30, or any numbers. Okay, so the first one here, if you can see here, okay, the variable a we put here is a equal to 100. So what happened is, okay, first, okay, from top to the bottom, okay, and the CPU will execute this line here. Okay, it will check whether your a is it equal to 10. If not, what happens is it will go to the next statement, which is else if is it a equal to 20, and then since the value a is 100, so this statement is false. Then it will execute the next statement, else if is it a equal to 30. Then in this case here, since the variable is still 100, which is the boolean the condition here is false, then you need to do the next statement, which is the else statement. So what happens is none of the, okay, and then since the else statement here is valid, or it true, then what happens is it will print out this code here, none of the value is matching. Okay, for example, let's put this A here, instead of 100, we put it 20. Okay, we just change this one here to 20. So first, it will go to the first condition. Okay, so this one here false. So it will check the second condition. Since the second condition is true, what about the third condition? Okay, so no need to run this one and the else statement as well. Okay, it will automatically go exit from that statement. Okay, if the condition are false for each of the this line here, it will go one condition to another condition. It will check one to another condition. Okay, so this is how the if statement works. Okay, so next we have the nested if statement. Okay, statement is used if you're going to check bit. Okay, for example here, in this case, you're going to check whether the value A and B is it equal to 100 and 200. Okay, so in this case here, okay, so you're going to check whether A is 100 and, okay, we have the N here, B equal to 200. Okay, so in this case, we're going to use the nested if statement. Okay, so first, what you're going to do is, okay, so this is the local variable. Okay, you can initialize your local variable, and then the first if statement that we're going to check is this one here. Okay, we're going to check whether A equal to 100. Okay, what happened when A equal to 100? When this condition is true, then after that, we check the second condition, which is it a B equal to 200. Okay, so in this case, you see if A equal to 100, yes. Yeah. Okay, so this one is yes, true. So what happens? You will go to inside of this if statement here, and then you check another condition. Is it P equal to 200? So this one is also true. Then you print out the statement. Okay, so value of A is 100 and B is 200. Okay, and then it will exit of this nested if statement. Okay, what happens if this one here, okay, let's say I put A is 50. Okay, I initialize my A is 50. What happened? Sorry. Okay, so since the first statement here, okay, the first condition here, okay, so it will go to this first condition. Okay, this is the first condition, and this is a nested condition, which is your second condition. Since the first condition is false, then automatically it will exit of this nested if statement. Okay, it no longer do the check the second condition because the first condition is already false. Okay, so this is how the nested if statement works. Okay, any question?
No, sir.
Okay, no. Okay, great. Then next we go to the switch statement. Okay, so a switch statement allows a variable to be tested for equality against a list of values. Okay, so each value is called a case, and the variable being switches on is checked for each switch case. Okay, so you have the switch and you have a case. So the value here that you're going to check is, we call it as a case, and then this whole thing here, we call it as a switch statement. Okay, so let's look at this flow chart here. You have an expression, okay, and then from this expression, we're going to see whether each line of this case is true or not. Okay, so first we look at the first case. Okay, is it the case one is true? If not, what happened? You check the second case. If the case one is true, then you execute the code block in one and exit from your switch statement. If not, okay, you need to check the second case. Okay, and then for the second case, okay, again, you need to check whether the case 2 is true or not. If true, you execute this code block 2. If not, you need to check the following cases until the last case, which is your default case. Okay, so if all of the cases here are false, then you need to execute your default case, which is after that you execute this code block add. Okay, so this switch statement actually it is similar to if else if statement. Okay, but this one is more what we call here more efficient compared to if else if statement. If you have many conditions to compare, so better we use the switch statement. If you have a less condition to compare, you can use the if else if statement. Okay, so let's look at this example here. Okay, so this is the program. Okay, so this program here, you're going to check, okay, the value of your grade. Okay, see, okay, this is the starting of your program. Okay, and then this is your main program. Okay, you see there, you're going to check the expression of your grade. What is your grade? This is a B. Okay, so you're going to check whether okay, the case for your the grade is B, or what is the output for this B grade. Okay, first what it's do is, okay, since you have how many cases here, you have 6 cases. Okay, this is case number 1, 2, 3, 4, 5, and your default 6. All right, so in this case here, okay, the CPU will go case by case. Okay, starting with case number 1. Okay, since the case number 1 is A, which is false, not equal to B, so this one is false. Then what happens is it will go to case number 2. Okay, and then it check the grade, whether the grade is equal to this or not. Since this one is B, okay, the grade is B, and then the case B also B, so it is equal. So this one here becomes true. What happens is it will produce, or it will print out, okay, this statement to, okay, and then what happens after that? Okay, the switch statement will be exited. Okay, because this one already true. If this one here, the case 2 is false, then you need to do to check the third case. Okay, so this is how the switch statement works. Okay, you need to check the value. Is it the value of your switch? Is it equal to this one or not? If equal, then you do that statement. If not, you need to check another case. Okay, for example, we change this one. Okay, the grade, instead of B, now we put E. Okay, change to E. What happened? Okay, so we go line by line. Okay, for the case 1, what happened for this one? It is false. So you need to check the second case. Okay, since this one also false, you need to check the third case. The third case also false. Okay, then you need to check this one. The fourth case also false. So you need to check the fifth one. Okay, since this one also false, then what happen is you need to run the default, and then it will print out the invalid grade. Okay, so if none of the cases is true, then you will give the default value. So any question up until here? Okay, next we are going to to look at the testing value. So in C programming, the conditions are evaluated on the basis of zero and non-zero. For any non-zero will be considered as a true, while zero will be considered as a false. Okay, so here is an example of the valid expression. Okay, let's look at the first instruction here. Okay, the first expression. If a greater than 3, so this one here is a valid expression. Why? Because the condition here, you're going to check whether your value a is greater than b. Okay, what about the second one? This one also a valid expression. Okay, if a equal to 3 and b equal to 2. So in this case here, you're going to check whether your a greater than 3 and b equal to 2. Okay, if both are valid, okay, if both are, this one, the first one is true and the second one is true, then this statement here become true. If one of this statement here is false, contohlah, this one is true, but this one is false, then this one become false. Okay, and then the third one, if one. Okay, so this one is useless lah. Why? Because it will always true. Okay, it always execute your block or your statement. So this one you cannot use this one lah. So this is useless. What about this one here? If 0, so this is always false. Okay, also useless lah. Okay, because you never going to execute your if statement. Okay, you never execute your block or your statement. What about this one? If 3 or with 6, since this is a 3, you or with 6, you always produce a 1. Okay, which is a non-zero, so it is always true lah. Okay, so this one also is useless. Because why? Because always execute your statement. Okay, and then we have, what about this one here? If a equal to 0, okay, so this one expression is valid, a valid expression. Why? Because you're going to check whether your a, the variable a, is it equal to 0 or not. If your a is 0, then it becomes true. If your a not equal to 0, then it becomes false. Okay, so what about this one here? Okay, exactly same as above, because you're going to check whether your a equal to 0 or not. Okay, and then the second last here, the second last statement here, what about this one? If a equal to 0, so this one here, what? It is a not valid. Why? Because you, now what happened is you going to define your a equal to 0. Okay, not you're checking your a, is it equal to 0. Okay, this is you're going to define your a so that your a will have value 0. Okay, and then the last one here, this is also a valid instruction, which is you're going to check whether your a here is it equal to 0 or not. Okay, so this is a better way lah to check if your a is 0 or not. Okay, is you can use either a equal to 0, or you can use the 0 equal to a. It doesn't matter. Okay, it do the same things.
Excuse me, doctor.
Yeah.
Can I ask you? Just The one before the last one. If A equals 0, I didn't get it.
Okay, for the A equal to 0 means that, okay, for this one here, you saying you give the 0 to your A. You're not checking the A value. You
Yeah.
give that the A with a 0 value.
So it's not condition.
It's not
Right?
condition.
So
Because
yeah.
this one here, you define your A, it is 0. Okay, so
But I
this
mean, if statement here will not execute, right?
yes, this one is not execute because
Yeah.
always 0.
Thank you very much.
Welcome. Okay, next we are going to see what is function. Okay, you already learned about the loops. Okay, the if-else statement, the data types, and then the bit operation, the arithmetic operation. Now we're going to see how the function works. Okay, what is the function and how they works. Okay, a function is a group of statements that together perform a task. Okay, so every C programming has at least one function, which is, okay, this is the function that you always use in your C programming, which is int main. Okay, so this is your main program, your main function. Okay, at least in C programming, at least you write this function here. Okay, and all the most trivial program can be defined additional function. Instead of this function, you can have a few functions such as a delay function, for example, input function, output function, or to read to display a LED. So you have the LED blinking function, for example. Okay, so you have multiple functions. Okay, that you can create. Okay, so a function is actually a set of statements that takes input, do some specific computation, and produce an output. Okay, so the idea why you're going to use the function is, okay, because you want to put some commonly or repeatedly done tasks together and make a function so that instead of writing the same code again and again and again for the different lines or different inputs, we can call the function. Okay, for example, okay, I give you a simple example how to use the function. Okay, when you're going to write a program that do to display a blinking LED, for example. Okay, so this is your LEDs. Okay, I have 8 LEDs. Okay, this is the first sequence. The first sequence I want to lights up this LED while the rest is turned off. Okay, then I want to what we call here to call a delay. Okay, because if I not put the delay, for example, delay 1 second. Okay, if I not put the delay, our eyes cannot, our naked eyes cannot see the difference between the first sequence and second sequence because it's very fast. Okay, so the second sequence of my LED blinking is this one. I'm going to turn it off, and then this one I'm going to turn in on. Okay, this second, third LEDs. Okay, the third sequence. Okay, this one is turned on, and the rest is turned off, and this is my fourth sequence. Okay, I'm going to turn this one, and the rest is off. So I write down the program. Okay, for example, okay, so LED, so this is my output equal to 0B10000000. Okay, once refer to this one because I want to turn it on, so I put 1, while the rest I put it 0. So that's why the rest will be turned off. Okay, then I have a line of coding, okay, to create this delay here. Okay, so this is a delay coding. Delay 1 second coding. Okay, then what happen is, next I'm going to display the second sequence. Okay, LED 0B 0, 1, 0, 0, 0, 0, 0, 0. Okay, then I'm going need, okay, because okay, and then I need to what we call to write the same delays, okay, in order to display the second sequence. Okay, because the delay between the first sequence with the second sequence is same, which is 1 second. So I write down the same delay coding here. Okay, so this is a delay 1 second. Okay, and then third sequence I also write down the same things. Okay, let it 0B 001 0 0 0 0 0, and then I write down the same delay. Okay, the same programming here and here. Okay, so instead I write down the same programming or to call out this delay 1 second, why not I just replace this one, okay, by using a function. Okay, so I put this one here. Okay, so this is my function void delay 1 second and void. Okay, under this function here I write down the delay that I'm going to generate this 1 second delay. So what happened is now I can, okay, I can reduce my programming here in order to what we call to display this LED blinking. Okay, from this okay, so I just write down something like this: LED equal to 0B10000000, and then instead of I write down this line here to create a delay, so I just call this function delay 1 second. Okay, same applies to this next sequence 0B 01000000, and then I just call the delay 1 second function. Okay, so now you can see here, okay, this one here, okay, the program here at my right hand side, okay, this I call it as a program A. Okay, this one here, if you see, you you have a longer program compared to this one. Why? Because we use the function called a delay 1 second, okay, to generate your 1 second delay. Okay, instead of every time you're going to generate a 1 second delay, you write down the same program over and over. Now you just call the function. If okay, every time you're going to what we call here to call the delay 1 second. Okay, so this is this is why we're going to use a function, because we want to reduce our programming. Okay, so this is an example of function. Okay, so this is your main program. Sorry, this is your declaration. Okay, you're going to include this file, and this is your function. Okay, this function here called a max function. Okay, in which in this max function here you're going to see, okay, you're going to see between these two numbers which one has a maximum, which one has a greater value from one to another. Okay, so this is your main program. Okay, so you just initialize your what we call here your variable A and B, and then by using the function max, okay, you're going to check which variable has a greater value, okay, bigger value. Is it A or B? Okay, and then what happens after whenever every time you execute the max function, it will go to this function here, and then it will see lah. Okay, is it A is bigger or B is bigger, and then after that it will return the value here. Okay, so this is how you use the function and call the function. Okay, the parameter that you are passed to the function are called actual parameters. Okay, so for example, in the previous example here, we can, okay, value 10 and value 20 are your actual parameters. Okay, in this case here, this one and this one, this is your actual parameters. We call it as a actual parameters. Why? Okay, the parameter that received by a function are called a formal parameters. Okay, for example, in the above program, x and y are your formal parameter. So this one, okay, since you receive the actual parameter, so this one we name it as a formal parameter. Okay, so this is a formal parameter. Okay, while calling a function, there are two ways in which argument can be passed to a function. One we call it as a pass by a value. The second one we call it as a pass by reference. Okay, what are the difference between pass a value and pass by reference? Okay, if you're going to use a pass of a value, the value of actual parameters are copied, okay, to the function formal parameter, and the two type of a parameter are stored in the different location. So any changes made inside of the function are not reflected in actual parameter of caller. Okay, so later we will see, okay, what the pass by value actually works. Okay, while for the pass by reference, both actual and formal parameter refer to the same location, so any changes made inside the function are actually reflected in your actual parameter of caller. Okay, means that, okay, this one here, anything that you, for the pass by reference, anything that you made a change inside your function here will be reflected to your actual parameter. Okay, if you're going to use the pass by value, anything that change here will not reflected to your main program, to your actual parameters. Okay, so let's look at the examples here. Okay, this is a pass by a value. Okay, so the call by a value method of passing argument to a function copies the actual value of argument into a formal parameter of the function. Okay, so you can see here. Okay, so this is your variable a and b. Okay, in this example here, you're going to swap the your value. Okay, since your value a is 100, b is 200. Okay, so every time you call the function swap, what happen is you're going to swap the value of a and b, so that your a equal to 200 and b equal to 100 after you execute this line here. Okay, so since this one here you use a pass by a value, so what happen is, okay, so this actual parameters, okay, the actual value will be go to here. Okay, so a b will be go to your formal parameter of the function. Okay, so inside here what happen is, okay, if you see line by line, okay, first you initialize your temp. Okay, so temp equal to x. What happen is now temp equal to, okay, since this is a is your x, b is your y, so temp equal to 100. Okay, for this line. Okay, the second line here, what happen is x equal to y. So x now will get 200. Okay, then y equal to 10. So y equal to 100. Okay, so what, okay, after you execute this line here, so now it will go back here and then it's going to print out what is the value. Okay, so when you're going to when the CPU going to print out this statement here, what happen is, okay, the value of a and b are remain at 100 and 200. Okay, Okay, so this is the output. Okay, before swap, the value of A is 100. Before swap, value of B is 200. But after the swap function is executed, what happens is the value of A and B are remain at 100 and 200, not this value here. Okay, why? Because the changes that made to the parameter inside the function, okay, any changes that made under this function here are have no effect on the argument. This is why, because you are going you pass the actual value to your formal parameters. Okay. Next, we are going to see pass by reference. Okay, so when the call by reference method of passing argument to a function. Okay, so when you use this pass by reference, so what happens is this method passing the argument to a function, copy the address of argument into the formal parameter. Okay, so in this case here, if you see here, this is the same program, but the difference here, okay, we use this star here, the pointer register. Okay, this is the pointer. Okay, instead of you send the actual numbers, the actual value, now you send out the location of that value. Okay, so you copy the address of an argument into the formal parameter. So you go to the location of A, copy the value and put to your X and Y. Okay, so then what happens is inside of this function here, okay, same as the previous. Okay, so this one here, X will have the value of A, B will have the value of, sorry, Y will have the value of B. Okay, so temp, this temp here will get hundreds. Okay, X will have 200 and Y equal to 10, which is 100. And then, okay, inside the function, the address is used to access the actual argument used in the call. Okay, so what happens is, it means the change made to the parameter affect the pass argument. Okay, so after you execute this one here, this value will be stored to this location, and it will be displayed, okay, to this statement or this arguments here after you execute your swap instruction. Okay, so this is the output. Before swap, A 100, B 200. After a swap is executed, okay, the swap function is executed, the value of A now becomes 200 and 100. Okay, so this is the difference each between pass by value and pass by reference. Okay, so in this pass by reference, it shows that the change has reflected outside the function as well. Okay, not inside the function, and outside the function, the value also changes. Okay, so that is the difference. So this is the important point. So every C programming has a function called main. So if you don't have any function, at least you need to have this main program function. So every function has a return type. Okay, if a function doesn't return any value, then void is used. Okay, so if you don't have any return value, then you need to use a void lah. Okay, function can return any type except array and function. Okay, so this is the important point to write down your in the functions. Okay, any question up until here? Okay, if no question, then we go to the C processor and macros. Okay, so the C processor is a microprocessor that transform your program before it is compiled. Okay, before you do the compiling, okay, the preprocessor need to be done first. Okay, so this transformation can be inclusion of your header file and your macros expansion. Okay, so the preprocessor will transform the program before it's compiled. Okay, so this preprocessor will include any file that you are going to include in the program by using the hash symbol here, such as you're going to include this file. Okay, you just use the hashtag include. Okay, and then if you're going to define what we call here any macros or variable to initialize, so you can use the word hashtag define. Okay, so this is your C code. Okay, every time inside of your C code include has this include hashtag include and hashtag define, the processor will transform this one here before you do the compilation. Okay, so this hashtag includes is used to include your header file, while hashtag define are used to do the macros. Okay, to define any variable with any with the defined values. Okay, now we're going to see what are the difference between the macros, the define, and the function. Okay, so macros are preprocessed, which mean that all the macros would be processed before your program compiled. However, functions are not pre-processed but need to be compiled. Okay, that is the difference between macros and function. Okay, macros no need to do a compile. Okay, it already be that in your pre-process, but a function you need to do the you need you are going to do a compile before you can execute this program here. Okay, so let's do the difference between macros and function. Okay, so this is your program. Okay, you include this file here, and now you see here this is the macros. You're going to define number with 10. Okay, so every time you see the label or the words numbers, the micro your CPU know that it is the value of this number here is 10. Okay, so this is your main program. Okay, printf percentage d, okay, number. So what happen is the output here will be equal to 10. Okay, because you already defined number equal to 10. Okay, while function, okay, what happen is, yes, yes,
I'm sorry, just what about the data type? When we use define, no need to mention to the data type?
no need to mention the data size.
No, no, data type, like
The data type.
integer or character or something like that. So
Okay,
here,
for the
yeah.
because this one here is a pre-process. Okay, you no need to define the data type.
So if we want to declare, for example, character, so just we need to use hash define, for example, char and a, for example.
Okay, you just put that if you're going to define it a character, you just put define a and what is the character that you're going to put. Okay, no need to define the data type.
Yeah, thank you.
Okay, well, for the function, okay, so this is the function. We're going to do the same thing, okay, as a macros here. Okay, first if, okay, so this is your function. So you just, what we call here, include the file, okay, stdio h file, and the int number. So this one here, this is your function, okay, name numbers, okay, and then what value that you're going to return. Okay, every time you see every time you call this function number, it will return 10. Okay, so this is your main program. Print percentage D number. Okay, so this one, so you see here, this is a number function. So what happens? It will go to this function here and it will return 10. So the output that will be print out here also 10. Okay. And then let's look at another examples. All right. So this one here, you're going to calculate the cube. All right, the volume of your or okay, the volume, the cube. Okay, so this is the how you're going to do. Okay, so include studio the hash and then you define cube p, okay, equal to b multiplied by b multiplied by b. So this is the formula how to calculate the volume. Okay, so in the main program, print f, okay, and then you have the okay, the decimal number, okay, that you're going to display in your printf, cube 3. Okay, so what happened is, okay, since this is a 3, so 3 multiplied by 3 multiplied by 3, okay, because 3 is your b actually, so b multiplied by b multiplied by b, which is equivalent to 3 multiplied by 3 multiplied by 3, so the print out here will be 27. So this is for the macros. And for the function, alright, so first, you need to initialize your function called a cube. Okay, so this function cube here, you make it as an integer a. Alright, so then you're going to return a multiplied with a multiplied with a. So this is the formula for volume. Okay, to calculate the volume. Okay, so under the main program, okay, so you write down this one here, print percentage d cube 3. So 3 here is your value that you were going to put to your function here, which is a here. So the CPU know that, okay, so this one you're going to 3 times 3 times 3, and the output also 27. Okay. So this is another what we call here example for the macros. Okay, so this one here you define pi with this value, and then every time you see the word pi, okay, so it will replace the with 3.1415. Okay, while this one here you can use the macros, okay, to define a function. Okay, for this one you define a pi with 3.1415, and then you define a circle area, okay, to calculate a circle by pi multiply with r multiply with your r. Okay, so if you see here, this will give you your circle area, the value of the circle area by using this formula. Okay, so this is how the macro works. Okay, and then okay, for the more secret, you can do it by yourself. Okay, you can run this one and see what happened to each of these lines here. Okay, so any question? So we finish our module 5, the C programming. Okay, next week we'll continue with the new module.
Please, if you have recorded the class, could you share it with us?
Oh, I'm sorry. Today I forgot to do any recording. I'm sorry, but I really forgot to do a recording for today.
Okay, it's okay.
Prof, I have a question about when the program writes if statement, if for example, if A like this, if A 100, if B 200,
Yeah.
when the program check if A not 100, directly go to print out the result, yeah?
It will not print out the result.
Oh, what's happened then when the statement is false? What happened here?
Okay, for example, we take this one here. Okay, we take this example.
Mhm.
Okay, I just erase this one.
Doctor,
Yeah.
I have a test right now. I have to quit.
Okay, never mind. You made this piece. So
Okay, thank you so much for the lecture. Thank you.
okay, welcome. Okay, good luck in your test.
Thank you so much.
Okay, so let's look at this one here.